This video is sponsored by LearnSQL.com. More about them later on. In this third and final part of my Data Analyst Portfolio SQL project, we're going to be designing and building dashboards using data we collected in the database we designed in part 1 and then wrote custom SQL queries for in part 2. Let's dive in. Hello and welcome to Learn BI Online with me, Adam Finer, helping you do more with data. So if you're just here for a dashboard design tutorial, keep watching. But if you'd like to follow this project from the start with part 1, I'll put a card up here and a link in the description as well. Just to recap, in part 1, we designed and built a relational SQL database for a fictional pizzeria. Then in part 2, we wrote custom SQL queries to give us the data we need to now connect to our BI tool and build the dashboards the client wants to help him monitor his business activity. There are 3 different dashboards that the client has asked for, one for orders, one for inventory, and one for staff. We'll build out the dashboards in that order. Firstly, I'm going to talk about the tools I'll be using and where the data is being queried from. For this exercise, I'll be using Google Data Studio as our BI tool. The reasons being that it's free to use, so you can follow along, and it has all of the functionalities we're going to need. The data we'll be visualizing is in a database inside of a Google Cloud MySQL instance. If you'd like to know how to create a similar instance, let me know in the comments and maybe I can make a video tutorial. But for this video, I'm just going to show you how to connect to the database using our BI tool. If you use a different BI tool and you'd like to reproduce this project, you can get your hands on a SQL dump file via the link in the description that will allow you to recreate the MySQL database anywhere you like. Okay, that's the housekeeping out of the way. Now let's connect to our database and build our first dashboard. To create our first data source in Data Studio, I'm going to click the Create button and select Data Source. Now I need to find and click the Cloud SQL for MySQL connector here. In order to connect to the database, we're going to need 4 pieces of information. First, the instance connection name that I can find in the Google Cloud backoffice, then the name of the database we want to connect to, followed by a username and password that you can set up also in the Google Cloud backoffice. Once I authenticate, Data Studio will communicate with the database that will return a list of all the tables and views that are available. You can see here all of the different tables as well as the Stock 1 view we created in the previous video. You'll also notice that we have the option to select Custom Query. This is what we're going to use. Here's the query that we wrote for the Orders dashboard in the previous video. Again, if you'd like to get your hands on this and all of the other queries we'll be using today, just use the link in the description. I'm going to copy and paste here and hit Connect. Now we're presented with the data source schema, i.e. all of the fields it contains. What we need to do now is to check that all of the fields have been attributed the correct data type. Created at is date and time, delivery is Boolean, delivery address 1 has been assigned as text, which might be okay, but it would be better to specify it as geo address. Address 2 contains no data, so I'll just leave that. Delivery city is city and delivery zip code needs to be changed to geo postcode. Item category and item name are both text, that's fine. Item price, I'm going to choose currency USD. Order ID has been assigned date, not sure why. So let's make this text because it's qualitative. And finally, quantity is a number. Great. Let's name this data source Orders Data. I'm now going to hit Create Report and add our new data source. And we'll find ourselves in the Report Builder, ready to start building our first dashboard. Looking at the client brief for the orders dashboard, we can see that there are 10 data visualizations or queries that he would like to include. Total orders, total sales, total items, average order value, sales by category, top selling items, orders by hour, sales by hour, orders by address in a map, and orders by delivery and pickup. Starting with total orders, we're going to want a scorecard visualization because it only displays one single KPI figure. Unless you're comparing date periods, then you'll have a figure for the difference between the two figures. Anyway, we're just going to show total orders. The calculation for this will be a distinct count of order IDs. For those of you unfamiliar, a distinct count returns the number of different values in a column, whereas a simple count will return the number of rows containing any value, or to put it another way, the number of non-blank rows. If we count the number of distinct order IDs, this will give us the number of orders. I'm just going to delete this table that Data Studio added and then add a scorecard. By default, we've got record count, which is the count of the number of rows in the dataset, which I'll replace with order ID. You can see here it says CTD, which stands for count distinct. It's the aggregator used for the query, and it's what we're looking for. We have a total of 58 orders. We're going to want to change the name of the KPI that's displayed by clicking on the pencil icon. Total orders. Great, we now have our first visualization. Next up is total sales, i.e. the amount of money these 58 orders generated. To calculate this, we're going to need to create a new calculated field that will multiply the item price by the quantity. I'll hit Add a Field, call this Total Sales, and write the formula item price multiplied by quantity. Save and finished. I'll now add another scorecard and use our new calculated field. There we go. All that's left to do is to turn it from a simple number into US dollars, and in the Style tab, I'm going to choose Compact Numbers. Number 3 on our brief is total items, so this will yet again be another scorecard. What I'm going to do here is simply copy and paste this second scorecard using my keyboard shortcuts and add the quantity metric to the query. We'll also want to rename it to total items. You may at this point be wondering why I'm not talking about the design aspect of the dashboard. Well, that's because at this stage, all I'm interested in is creating the 10 visualizations asked for in the brief. Once I have all of these on the dashboard, I can then start to think about things like widget size, placement, colors, etc. Basically, we'll be building the dashboard in 2 phases, queries and then design. Point 4 is average order value. To get this figure, we'll need to divide total sales by total orders, so another calculated field. I'll call it average order value and type in the formula. Sum total sales divided by count distinct order ID. You might be wondering here why I'm using the sum aggregator for this formula, whereas I didn't for the other one. The answer is that the total sales figure needed to be calculated on a row-by-row basis, whereas here we want the sum of total sales divided by the distinct count of order ID. Again, I'm going to copy and paste this other scorecard and replace the metric with average order value. We're also going to change this from a number to USD. You might be thinking that this figure is quite high, and you'd be right. That's what happens when you allow people free rein to order anything they like from a fictional pizzeria. Normally, I would have removed the unrealistic orders from the dataset, but as there weren't that many to begin with, I decided to leave them in there. If you decide to get a copy of this data, you can obviously modify the values any way you wish. You could also add more orders if you like. Okay, the next point, point 5 of the brief, asks for sales by category. So we'll need the total sales metric broken down by item category. For this, I could use a column or bar chart, but I'm going to use a donuts chart because there are just 4 values and I think it's best suited to the query. A donut chart is simply a pie chart with a hole in the middle. Let me add one to the dashboard. Now let's add total sales as our metric and item category as our dimension. Looking good. You might now be saying, but if you use a pie chart, it'll look more like a pizza. That'd be really cool. But no, the purpose of the dashboard isn't to look cool. It's to display as effectively as possible the data within it. There's also the ink to data ratio to consider, and a donut chart uses less ink to display the same information and gives the data more space to breathe. For more information about the ink to data ratio and other dashboard design tips, check out the link in the description. Point 6 is top selling items. For this, I'm going to use a bar chart. The reason being that it shows the values vertically, which evokes hierarchy better than a column chart does. I could use a simple table, which would also show the values vertically, but the length of the bars will also allow us to easily see how the values compare. You might suggest using color encoding for the values of a table, but still not as effective as a bar chart. So, with total sales as our metric and item name as our dimension, I'm just going to drag the y-axis to the right to increase the area available for the item labels. Great. Points 7 and 8 are orders by hour and sales by hour. I'm going to put these together into a line chart. You might be thinking that a time series chart would be better if we're using a date time field, but I'll show you what happens when we do. I'll first change the date time level to hour, and you can see that we only have data for the opening hours of the restaurant, meaning the rest is blank. And with the time series chart in Data Studio, all values of the date or time level used must appear in the chart. You have options in the Style tab for what to do with missing values, but neither line to zero, line breaks, or linear interpolation are what we need. Nope, just going to have to use a line chart instead, which also means we'll need to change the sort method to hour descending. Next, I'll add in order ID for total orders. That's no good. Because the scales used by the 2 different metrics are vastly different, we'll need to go into the style options and put total orders onto a right y-axis. And finally, let's change the name of the metric to total orders. And that is point 7 and 8 taken care of. Point 9 is orders by address in a map. So let's add one to the dashboard. We're going to use a Google Maps bubble map. We can see that Data Studio has added Delivery City, but looking at the map, we can see that we've got one bubble on the east coast of the US and another in the UK. The reason for this is that the delivery city for some orders is Manchester. Our pizzeria is in the United States, so we need to somehow add in the country to the query as well as the full delivery address to be able to plot all of the bubbles. But there's only one field allowed for plotting the location. So how do we solve this problem? Well, we're just going to have to create a new field that concatenates the different address fields and adds United States at the end. Let's do this now. We'll call it full address and use the concat function. Inside the parentheses, we'll type delivery address 1, comma space in quotes, comma delivery city, comma space in quotes, comma delivery zip code, comma space in quotes, comma United States in quotes. Save and finished. Then we'll replace the current dimension with our new full address one. That's better. Now we'll zoom in to see the different bubbles. You might notice 1 or 2 bubbles plotted far from the Manchester cluster. That's because I generated these random addresses using a random address generator online. If we're dealing with a much larger dataset, or if it was a real-world dataset, I would investigate a problem like this further and clean the data. But all I'm going to do here is to zoom in to see Manchester only. One last thing I'm going to do is to add total sales to the size metric, and we're done. The final query the brief asks for is to show orders by delivery and pickup. We can create this by adding the delivery dimension to a pie chart and then use the distinct count of order ID as the metric, like so. And we're done. We have now added all of the 10 required visualizations to our orders dashboard. Before we move on to the next inventory dashboard, a quick word from the sponsor of today's video, LearnSQL.com. If you want to learn or practice SQL, check out LearnSQL.com. They have a set of over 50 hands-on SQL courses. This unique platform offers a 100% online experience with nothing to install. Everything happens through your favorite web browser. All of the courses are interactive and based on real-life business scenarios, meaning you'll be writing SQL queries and seeing the results instantly. Do you want to become a data analyst or encourage your company to be more data-driven? LearnSQL.com is the place to go. You'll find a link to LearnSQL.com in the description below for you to check out their offer and choose one of their learning paths in SQL, PostgreSQL, or T-SQL. With LearnSQL.com, learning SQL has never been easier. So here we are back in Data Studio, and here is part 2, the inventory part of the dashboard brief. We have total quantity by ingredient, total cost of ingredients, calculated cost of pizza, percentage stock remaining by ingredient, and list of ingredients to reorder based on remaining inventory. I've already gone ahead and created the 2 stock data sources using the custom SQL queries we wrote in part 2. The first thing I'm going to do is to add a new page to the report from here. Then on the right, I'm going to name the first page orders and this new page inventory. So the first 2 points both include ingredients, and because we have over 40 ingredients and products that we need to report on, I'm already thinking that the best way to visualize this data is using a simple table. Let's add one to the page by dragging ingredient name from the field list. Now we just need to add our metrics. First is total quantity, which is our ordered weight metric. And then total cost, which is our ingredient cost metric. Let's sort by ordered weight. I'm going to rename the fields as total quantity and total cost. And then add a summary row to give us our column totals. But it doesn't make much sense for the quantity column because the unit of measurement is different for different products and categories. So what I'm going to do instead is to add a scorecard showing just the total ingredient cost figure. Then we can uncheck the summary row. Next up, we've got calculated cost of pizza. And for this, we're going to need to add a new field that multiplies the recipe quantity by the unit cost. Let's go ahead and do this. Again, we're going to do the calculation row by row, so we don't want to include the aggregators. Now, let me drag item name from the field list and add in our new cost of pizza metric. Great. But what I also want to do is to filter the table on just the pizzas. And to do this, I'm simply going to add a filter from here. Call it pizza only and include from item name contains pizza. And it's done. We can also change the data type to currency USD and sort on cost of pizza. We can see that the seafood pizzas cost the most to make. For the final 2 points of the stock brief, we're going to use the second data source we wrote a custom query for in part 2. percentage stock remaining by ingredient, and a list of ingredients to reorder based on remaining inventory. If we think about it, both of these are pretty much asking for the same thing and are going to be referencing the same data, i.e. the amount of inventory remaining will also show us which ingredients need to be reordered based on this figure. All we would need to do is to use conditional formatting to highlight ingredients and products in the table based on the percent remaining. Sounds good? Let's do it. I'm going to start by adding a table from the correct data source by dragging ingredient name and then adding the metrics total inventory weight and ordered weight. So the percent remaining will simply be the difference between these two divided by the total inventory weight. Let's add this field now. Percent remaining as total inventory weight minus ordered weight in parentheses divided by total inventory weight. Then I'll add this to the table. I'll need to change the data type to percent. And I don't need the two original metrics, so I'll remove them from the table. This is all looking good so far in terms of the fact that we've got everything we've been asked to include in the dashboard. But I'm not happy with it, and I think we can make it much better by combining these two ingredient tables into one. You might think that this would be complicated due to them coming from two different data sources, but it's actually really simple, and we can use one of Data Studio's more advanced features. I'll just select the two tables, right-click and hit Blend Data. This will create a third table that contains the data from both tables. And now I can just delete the two original tables. Much better. It makes our dashboard much more efficient and easier to understand. The final piece of the puzzle is to use conditional formatting to show which products and ingredients need to be reordered straight away and which will need reordering soon. In the Style tab under Conditional Formatting, I'll add a new condition, which will be if the percent remaining is equal to or less than 0.25 or 25%, then we'll colour the entire row with a red colour. Save and add another. Now if the percent remaining is greater than 0.25 and equal to or less than 0.5 or 50%, then we'll colour the entire row yellow. Now we just need to change the sorting method to ascending and we can easily see which products need reordering. I like it. Just going to jump in here quickly to say that I hope you're finding this video useful. If you are, please do give it a thumbs up and don't forget to subscribe and turn on notifications if you haven't already so you don't miss an upload. And remember, if you'd like to get a copy of the data we're using for this project, as well as the MySQL dump file for you to be able to recreate the database wherever you like, please check out the link in the description. Okay, back to the final part of the project, the staff dashboard. This third and final dashboard is going to be the easiest by far to build, as we'll only need two scorecards and a simple table with no calculations necessary. I've already gone ahead and added a new page and called it Staff. The first issue that we're going to need to address is the fact that the staff data source contains data for multiple dates, but the orders data contains only data for a single date. So we're going to need to apply a date filter to this whole page, so that we're just looking at the data for the same date as the orders. We will, however, add a date range control that will allow dashboard viewers to look at other dates if or when more data is added. First, we'll change the current page settings by right-clicking the page and selecting the relevant option. Data source, we'll choose staff data. Date range dimension is date, and we'll set a custom date range of the 10th of August, the date we have in the orders data. Next up, I'll add a date range control from here to the top right of the page. We can see that the date range is set to 10th of August. If we look at the client brief, we can see we have just 4 points: total staff cost, total hours worked by staff member, and cost per staff member. Starting with total staff cost. This is going to be a single figure, so we'll use a scorecard visualization. I'll add one here and replace record count with the staff cost metric. Then we'll rename our metric as total staff cost. For total hours worked, I'll simply copy and paste this first scorecard and replace the metric with hours in shift. Then rename the metric to total hours worked. Perfect. The final 2 points, hours worked by staff member and cost per staff member, can be put into a table. In fact, what I'm going to do is just recreate the data source table by adding all of the metrics and dimensions. So I'll add a chart, and in dimensions, we'll have first name, last name, start time, and end time. And in metrics, we'll have hours in shift, hourly rate, and staff cost. Great. If I double click any of the column lines, the columns will resize to fit. There we go. That's our staff dashboard done in terms of queries. You might be thinking that I should increase the size of the widgets so there's less blank space on the page, but really there's no need. The data is easy to read as it is, and as reporting requirements evolve, there may be more queries added to it. It's fine as it is. So now we've created all of the queries asked for in the client brief. The next step is to add design elements, colors, etc. Let's go to theme and layout. In terms of branding, what we have is the restaurant menu. There are loads of pre-built themes we could use, but if we go right to the bottom, we can also use an image for creating a new theme. I'll just hit Extract Theme from Image and select the menu file. I think we'll choose this middle one. Looks good. There are a couple of other elements I'd like to add to all pages. The first is a rectangle at the top of the page. I'll first draw it and then right-click and select Make Report Level. Now, when we load the other pages, we'll see the same rectangle. Here on page 3, I'm also going to make the Date Range Control report level as well. Back on the Orders page, I'm going to add a page title. Orders. Okay, the next thing I'm going to do is to resize and reorganize the widgets on the page. Like so. This widget here needs more information to tell viewers what they're looking at, so I'm going to add text here. Delivery ? I think this is looking good, but there's something else I'm going to do to make it even better, and that's to make the grid lines lighter. First, for this table, by going to Style and Cell Border Color, we'll choose a light grey. It's actually best practice to completely remove lines from charts like this, as it increases the ink to data ratio and potentially distracts attention from the data itself. But rather than doing that, I'm just going to make them much lighter. So you can still make them out, but they're not distracting. When it comes to these scorecards, most people would add a border to them and even a drop shadow, but normally I don't. For the same reason I just mentioned a moment ago, it's just additional ink that doesn't really add to the legibility of the data. They're not really close together to begin with, so I don't see any reason for borders to demarcate them. Okay, let's move on to the inventory dashboard. We're going to need a title on this dashboard as well, so I'm going to go back to page 1, copy the orders text box, and then paste it onto page 2. And we'll change the text to inventory. Again here, I'm going to select the two tables, and in the Style tab, I'm going to change the cell border color to a light grey. Finally, on page 3, I'll paste the text box again and change it to staff, and then change the cell border color. The very last thing I'm going to do is to check to see if I need to add any more titles or text to the dashboards to make them easier to understand. A lot of dashboards I see add a title to every single visualization to tell the viewer what they're looking at, but this is often unnecessary. The reason being that a lot of the time it's very easy to understand what data you're looking at without the need for a title. Sometimes all you need to do is to add an axis title rather than a chart title, like this line chart here. The legend tells us that we're looking at 2 lines for total sales and total orders. The only confusing thing is what the x-axis represents. So rather than adding a chart title, I'm just going to add the x-axis title from the Style tab. For our bar chart, the legend tells us which metric we're looking at, as does our map. In fact, the only other piece of information necessary is the metric used in the donut chart. So I'm just going to add a small text box and type total sales. A quick glance at the other 2 dashboards tells us that no additional text or information is needed. So that, folks, is all. We've finished building and designing our 3 dashboards. For those of you who followed this project from part 1, I really hope you enjoyed it as much as I did making it. If this is the first of the 3 videos you've seen, I'd recommend going back and watching the other 2 parts starting here. A big thank you again to LearnSQL.com for sponsoring this video. If you're looking to learn SQL, why not check them out using the link in the description. Thanks so much for watching, and I look forward to seeing you soon for another video. Until then, stay BI curious.